Here we are. How to evaluate. I cannot stress enough the importance of this part, this video. Let's put some exclamation points on it. This is how we solve limits. This is the stuff that's very, very applicable to how you're going to be examined, or your tests and stuff. This will be back on the final. This is the majority of your test, is 2.3. This just how to evaluate a limit. I'm going to ask you questions like, just what's the value of the limit? Where's it going? And we're going to need to use some algebra, and we're going to need to use our limit laws. Now, we don't need to show our limit laws. We just have to follow the limit laws, just like in algebra. You don't have to write down every time, like, I'm using addition. You just follow the frickin' rules, and then you're right, or you're not. So, let's go. And I'm going to give you something that you would never be tested on. I would never give you something like this. It's too frickin' easy. Now, limit laws say we can break this up into two different pieces and then plug some values in, but, it says this. You have a function plus another function. Now, I'm going to write in pink saying, like, don't do this. Don't do this. Please don't do this. And say that this is the same thing as the limit as x goes to 2 of x, right? The first one, plus the limit as x goes to 2 of 5. And then we could use our limit laws and tell us that. Remember this one from back here where if you just have an x, you just plug in your a value? And we could say that this is actually just when you plug that in, you just get 2, right? And then what's the limit as x goes to 2 of the number 5? Remember that again? Remember that, like 5? It's just 5. So if x is going to 2, what's the height? It's just frickin' 5. So we find out that the answer is 7. Now I did that in pink to show you don't need to show all of these steps. That's not necessary that you show all those steps, because there's no issue. So you can show them. I did it through limit laws. But I'm now going to just get rid of this and say this is the way we should solve it. We look at our function, x plus 5. Like aside, we could say it's the same thing as like y is equal to x plus 5. That's just a line, right? Just some sort of line. Now we have to go to this topic, this one thing. It's called domain. Do you remember domain? It's all the shit you're allowed to plug into your function. All the values. So as long as that number is in the domain of our function, this number here, 2, there's no problems. Can you plug 2 in for x for y equals x plus 5? Do you think you could do that? You think that's going to be okay? Yes, because 2 is in the domain of the function. Domain means all the values of x you're allowed to plug into the function. Since there is no domain issue, there is no problem. All we do then is we just replace our x value up here with 2 and write 2 plus 5 is equal to 7. And there's our solution, because there's no domain issue. Another one might be something like this. What's the limit is x goes to pi over 3 of cosine of x. Well, shit. As long as I really shouldn't be doing a trig function shit, but I like doing it. Just saying like, hey, do you know that you can plug anything you freaking want into cosine? Any value of x? Y'all have seen a sine wave, right? Or a cosine wave. It goes on and on forever and ever and ever, saying you can plug in any value of x you like. Well, what it's saying is just take this shit. Go plug it in for x. It's in the domain of the function. So we could just say that that's cosine of, and write your a value in there, pi over 3. And that's just equal to 1/2. Beautiful. So if it's in the domain of the function, just plug the damn number and then go. That's all that's going to happen, except problems 1 and 2. I wouldn't do something like this to you until later in the class when you think it's always a trick. Here's a problem that we would actually deal with. Like this is a good one. There's almost always a domain issue, some sort of problem. So let's say we want to look at the limit as x goes to 3. And I don't know, let's make it x squared minus 5x plus 6, and let's pop that thing over x minus 3. Yeah, let's put that thing over x minus 3. Cool. This should be your first step. Back up here, you see problem 1 and 2. First step, take this number and plug it in for all your values of x's and just see what happens. I'm going to help you out real quick. when you plug it in over on the side, the top, when you plug in 3, you get 3 squared minus 5 times 3 plus 6 over 3 minus 3, right? We're just plugging in, anywhere you see an x, we're plugging in 3. And this turns out to be 0 over 0. And we've discussed it in past ones. This means do more work. This does not equal 0. This does not equal infinity or negative infinity. It means do more work. It could equal 0. It could equal infinity. We have no freaking clue. It could be anything. What we're going to do is we want to get rid of our domain restriction. That's not a problem if the numerator equals 0. That's fine. We all know you're not allowed to divide by 0. So we must make that domain issue go away. As long as we have this x minus 3 in the bottom, we're not allowed to plug that value in. That was from our fourth limit law. So this is how we're going to solve it. This is what we're going to do. We're going to take this problem and go, you know what? I remember we took algebra classes for freaking days, didn't we? Do you mind if we go through and just factor the numerator? You know what I mean? Just factor. Who knows? Maybe something will cancel. And almost always when you have a 0 over 0, you're going to be able to do some sort of fancy trick and be able to plug your number in. Usually. So we write the limit as x goes to 3. We got to keep writing that until we plug stuff in. Now our x minus 3 in the bottom is going to stay the same. But now let's factor. Let's factor x squared minus 5x plus 6. You all know how to factor, and this has got to be at least you taking 2 or 3 courses if you got here. Maybe 5 courses in just factoring. So we should know how to factor. So that ends up becoming x minus 3, x minus 2. You know, two numbers multiplied together that equal positive 6 and add up to be negative 5. Yeah, that's negative 3 and negative 2. Then once we're here, this is the game. This is what we wanted. We play this game so we can go, hiya, cancels. Do a little bit of algebra inside that limit. And notice our domain issue went away. Our domain issue is gone. We move to the right here and go, well, let's look. We write the limit again. So we're going to write everything. Well, we're not going to have this shit. That's gone. We're only going to be left with x minus 2. Well, oh shit. There it is. Take your number 3. Go through. And all we're going to do is go plug that thing in for x. And we're going to say that this is equal to 3 minus 2. So once we plug our a value in, we stop writing limit. 3 minus 2 is equal to 1. Yeah, we got it. We got ourselves a limit. This is the beginnings as to how we do these problems. So the game is domain issues. 99% of your problems in this section are going to have to do with the fact of there being a 0 in the denominator. The zeros in the denominator will create a bunch of problems for you, which means do algebra, cancel out, and go. There's a few other tricks, and I'll be showing them as we go through these videos. So here is the beginning. We want to cancel out domain issues, then plug shit in. I'll see you in the next one with some more example problems.